Okay. N is the number of pairs of data. These ones have to be the same. If this is a dependent test, they have to be the same. D is the difference between entries in a pair of data. For example, if we're doing weight loss, we might say this person is minus 11, they are negative 11 pounds. This one is negative 15, they've lost 15 pounds. This person is positive 6, which means gain 6 pounds. So positives and negatives mean a lot in this case. When you do standard deviation, you have to square them all, just like normal. These are the differences, the average differences. We square them, we divide by n minus 1. This is just a classic standard deviation thing. And this is the same thing here for means. All right, so using a t-test for the difference between means, dependent samples. Verify that they're random independent, that they're normal, or n is greater than 30. Null and alternative. This time, with your null and alternative, they always involve 0. So for example, it could be less than or equal to 0 and greater than 0.
This if there's change or not?
Not if there's change or not, if there's positive change or negative change or sometimes just any change at all. For example, I wouldn't want to sell a weight loss drug that automatically makes people gain weight. And that would be a difference, right? If I was like, look, there's a super big difference when people take this pill. And people are like, great, do you lose weight? And I'll be like, hey, I didn't say that. I just said there was a big difference. Okay, like, just because one is bigger than the other. We do want, sometimes you want it to be very positive and some you want it to be really negative. Like if it is your self-image, how you're doing, rate yourself on a scale today, 1 to 5. And 0 is horribly depressive and suicidal, and 5 is I'm amazing. Everything's going perfect in my life. Nothing could ever be wrong. Give yourself a score today. And if on average my anxiety medication moved your score up, then good. That's what it's supposed to do, right? But if on average my anxiety medication made you go down, that means it's the opposite of what it should do, and actually it's making you sadder or having more problems with my medication. So those greater thans and less thans do matter. Degree of freedom is n minus 1. Critical values, that's the edge of your rejection regions. D bar, S bar. I think we're just going to do all of this together. This is actually just like, do you remember the x minus mu over sigma divided by the square root of n? That was for t. It's exactly the same thing.
No, it's just D.
D bar is just the differences. So D bar, differences, mu sub d, s sub d, square root of n. It's all the exact same thing. Okay, so we're going to just try this. First thing we have to do is we have to start getting all of these numbers. We will in a minute. But first we're going to do some of this by hand because there's just no sense in doing some of this on a calculator when you can do simple math. All right, it looks like this shoe manufacturer claims that athletes can increase their vertical jump heights if they use their training shoes. Vertical jump heights of 8 randomly selected athletes are measured. What do we want to happen to their jump heights? Increase. All right, so I'm going to write h sub o, h sub a. Mu sub 1. And it's not mu sub 1, it's just mu, right? We don't use a 1 at all. So you don't say that they're compared to each other. You say that the difference, and so it's not even mu. I'm sorry, guys. I made a couple mistakes today on the front side, too. Shouldn't be mu's, it should be d's. The difference is greater than 0 or less than 0. D. Make sure I'm doing this right.
Where?
Well, they called it mu sub d. I guess that makes sense. So mu sub d, mu sub d. The difference. Both. All right, so I'm going to write it right here. H sub o, H sub a. Should I flip this? There we go. Mu sub d and mu sub d. What did we say we wanted to increase? So greater than 0. We wanted to increase. And here's less than or equal to. Okay.
Will the inequalities always be the same?
What do you mean?
Like, will it always be less than or equal to and greater than?
No. It could be greater than or equal to and less than. Like in this one, we want your vertical height to increase, right? But there are some things we want to decrease, like your anxiety levels. I would say, ooh, I hope that they decrease, or your weight. We're hoping that you have weight loss or whatever, you know? So it depends. Or sometimes they'll just say we want it to be different, or we want it to be, or I'm claiming that the IQ of a father is equal to the IQ of his son. That could be a two-tailed.
So the claim could be the null. So
Yeah, yes, the claim could be instead the null, or it could be the alternative. In this case, it's the alternative.
It could be, you want it to be greater than or equal to, or
Yes. But this one it says, or were you telling me something about this problem that I'm missing? No? It says they can increase. So that's where this greater than comes from in this problem. Okay. Now I really don't like how they've set this up, but we're just gonna have to go a little backwards here because this makes sense. Does the greater than make sense to you guys? We want a positive difference. But that also means that when we're doing all of our differences, so I'm gonna write differences underneath here. What should I do? Should I take the after and subtract the before? This is my before and this is my after. Should I take before minus after or after minus before?
After minus before.
After minus before. Does everybody understand that? Which is what's driving me crazy because I want to take the top one and subtract the lower one. But we got to go backwards here. So this one increased their height by 2 inches. This one increased their height by 3 inches. This one stayed the same. You guys get what I'm doing? What would it be for the fifth guy? -2. He got worse. This guy did better, this one did better, and this one did better. You guys getting the same thing? Now, D bar is just adding those all together and dividing by how many you have. Do you have to make them positive first? No, in fact, we want some of them to be negative because if it turns out that this is like, it's making you worse, everybody's getting, their vertical height is going down, then we need to know that too. So everybody add together, 2 plus 3 plus 0 plus 1. I got D bar is 1.75. Okay, all right. And now we would find the standard deviation of this. What we could do is we could take the difference minus the D bar, which would be every deviation, square them, take the square root, do that whole thing, but I'd prefer to do standard deviation on my calculator if that's all right. So I'm going to put stat, stat edit, and I'm going to put the differences in the list.
You don't have to delete the second list, right?
What?
You don't have to delete the second list, as long as you're only referring to the first one, you should be fine, right?
Sure. And then stat, one variable stats. If you did it right, your X bar should say 1.75. Because we just figured out that D bar was 1.75. Why doesn't it say D bar? Why does it say X bar?
doesn't know.
It doesn't know. Calculators are
Stupid.
stupid. They have no idea we're talking about differences. They're just like, you put the numbers in.